right, so let's get going, right? Where we left off is we developed this model. And where we're going to go today is to actually superimpose our planar superimposition project onto it, right? So now we're starting to get into warped surfaces and stuff like that. But at first, in order for you guys to understand the Grasshopper definition that I built for you, we're going to work in 2 dimensions, and then we'll apply it to this model, okay? So in order to do that, jump into your top view and just make a copy of this. And then open up Grasshopper. Just type in Grasshopper and it'll open up, if you don't recall. Give it a moment. Okay, so here's Grasshopper. I put the file in this location, so it's under the Assignment 10 Graphic Conceptualization file. So if you navigate there, you can actually just click and drag to open it up. That's what's pretty cool about the Grasshopper interface, is it's doing that popular thing now that most user interfaces do, where you can just click and drag and it'll open that file. It should look like this. So you can see that I've developed a custom cluster for you, and it will produce certain geometry. Okay, and we're gonna first develop this on the flat one, and so it's super mega simple. All you have to do is take this surface reference and plug in either a surface, or the cool thing that Grasshopper does is it'll take a closed curve and it'll create a surface for you. It'll just kind of skip that whole creating a surface step and assume that there's one there. So you right click that and you go to set one surface and you just click on that. Okay, maybe you can't. Hang on. Oh, I lied. You need to have this one right here. Curve. And then the curve will convert it directly into a surface. So set one curve and you can pick that polycurve and then you plug it into surface and it generates the placeholder surface for you. So I'm going to jump back into perspective here so that I can look at what's going on. What you see here is it's kind of the essence of what we're going to be doing, right? In a way. I want to first start off by hiding these 2 original references. You want to make sure that you don't see those because they're just going to confuse you. So middle mouse click button when you have those selected and disable the preview. And this is what you're left with. And let's get back into the top view. Actually, I'll show you in both views. Okay. And on the side view. There we go. So here is what's happening, right? This cluster, and I didn't name everything properly and give you descriptions or anything like that. If it's necessary, I can write in descriptions and all that, but let me explain what's happening. So obviously this S input is the surface, right? So what happens inside that cluster is it takes a surface and the term is called ReParameterizing, and basically what it's doing is it's reducing the boundary of that surface to a smaller proportional domain. So that essentially means that every single one of these sliders, the umin, umax, vmin, vmax, goes from 0 to 1, which is a percentage value from 0 to 100, right? So if you put your umin all the way to 0 and your umax all the way to 100, and your vmin to 0 and your vmax to 100, you're going to get a full panel. But if you switch, say, vmin to 50, that means you're going to get a panel that only goes halfway across that size, the size of that surface. Does that make sense? So it's purely a proportional relationship. So where I had it before, this was down at like 35 or something like that. It was pretty low. And then this one was at like 30. Oh, okay. Well, either way, doesn't really matter all that much. But what the point I'm trying to make is like we're composing things on the third lines, right? So if you're going to build geometry on the third line, you just need to put in the percentage of the way across the surface that you want it to be. So 1/3 across the surface is 0.33. So if you're somewhere around the 0.33 range, that's going to put this at the 1/3 line approximately. And you can do the math and you can make it exactly, like 0.33 plus 0.2 or 0.02 and then 0.33 minus 0.02, and you'll get, like an exact spread right on that line. And I'll show you that later on. But I want you to understand just basically what this is doing. So the last thing here, this layer 1 depth, and I see that I named something improperly, but layer 1 depth is actually creating a difference in depth for that element. So as you push this either up or down, you can see that it's extending the depth of that element, right? So we as the designers are going to be, let me zoom select on this, we're going to actually be designing the construct of our planar superimposition using layers of this kind of geometry. You guys get it? So here's kind of the second level, right? I moved this down, and you saw that it actually moved the other flat plane that's on it as well. Let me move that back to 100. Right? So as I move this up and down, the other one goes with it, right? That's because I take that same depth and I plugged it into the level depth of the next cluster or the next surface, right? And that creates the next B-rod. That's this one. So likewise, I can change the depth of that one. And if I create a third one, right, I just copy this down. And then you need to, the only thing that you need to do here then, if you're going to create a third one, is replace the level depth with the depth that you had before. And that would be this one. And the original surface will be referenced. Let's see, we had, yeah, went back to the original surface. So this goes back to the original surface. So that's this one. Oh, you know what? We're going to have to do some more math on that. I don't have it set up properly. It should combine all of them. Yeah, sorry. We just need one more math element. So you go to math, operators, and you add it. Right? So you take the original one, this, and you take the new one, which is that, and then you plug that into the level depth. So now, and I'll go through this again, but now you have a second one here that's, or actually let me expand this one instead so that it goes the opposite direction. There, something like that. Okay. So here you can see that that one lives below, and as you slide these up and down, that relationship is retained. Okay, so that's the objective here, is to change that. Okay, so if you think about it, all you're doing is you're taking this group of items and you're adding another group of items, right? So it's going to get a little crazy sometimes. And so what I would suggest is to just have a clear and controlled way of viewing these. So maybe just pull the cluster sort of way out when you're first starting to understand what's happening, and keep your layer depth a little bit separate from these perhaps, right? So that it just makes a little bit more sense. You can visually kind of see what's going on. Does that make any sense? So our objective here in the first part of class is to look at, and let me pull it up real fast before we, okay? So our objective is to look at our composition and try to emulate that composition, okay? And you're going to be stacking these things in a three-dimensional relationship with one another and composing that. Does that make any sense? Does it make 100% sense? That's good. Okay, I take your silence as a concession of understanding. Or, yeah. Anyway, so the other thing that I think you should pay attention to here, and I'll probably work, since there's only a few of you, probably work with you more one-on-one where it becomes necessary, is that for those of you who are brand new to Grasshopper, it might get a little confusing dealing with these pluses. Don't let it freak you out. It's not that hard to really conceptualize. All you're doing is you're taking these depths, right? Let's see, I'll group that, right? Group this one. All you're doing is taking those elements and you're just going to add them together to make sure that you have the right offset from the original surface for that element. Okay? All right, so you've got the file, you've got your file, so go ahead and let's get cracking on this. I'm going to give you guys a little while to move forward in trying to develop your particular definition with your particular graphic, but don't worry if when we move on you're not done, because the good thing about Grasshopper is you can just add it in later and it'll update and update, and you just keep going with it. It's very parametric. Okay? All right, let's do that.
And would the pick any one of the three that we did?
Any one of the three, yes. Yeah. So I would suggest maybe pick a simpler one for the first pass. Pick your simplest.